Total protein indicators or total protein swabs are designed to detect protein on equipment surfaces. They cannot discriminate between allergenic and non-allergenic protein, but the rationale is if a surface is protein-free, it is reasonable to infer that it will also be allergen-free. The swabs are easy to use, sensitive, cost-effective, and practical if you control multiple allergens. What is in the box? Generally, kits only have one or two components. The test devices, each housing a swab and its testing liquid, and a bottle of wetting buffer if the swabs are not pre-wetted. How do I do these tests? In 3 simple steps. 1. Sample collection. 2. Test activation. And 3. Dry incubation. Systems that can detect protein at very low concentrations require swabs to be incubated in a dry incubation block. Later in the video, I will show a demonstration of a popular total protein indicator test. At the end of the test, you can determine whether protein was present by comparing the color of the liquid at the bottom of the device to the color chart supplied. Depending on the chemistry, the liquid will either turn from clear into green or purple, or from brown into blue. Many popular kits employ the Biuret reaction, which results in the former clear to purple color change. Protein peptide bonds reduce cupric ions in the liquid to cuprous ions. When the liquid is heated, 55 degrees Celsius for 15 minutes, each cuprous ion binds with 2 bisanquinic acid molecules and form a purple-colored product. The intensity of the purple color indicates how much protein residue was present. It is important to keep a few factors in mind when using total protein indicators, such as, for example, AllerSnap. 1. It measures total protein and does not differentiate between allergenic and non-allergenic protein. Thus, some positive results may not be due to the presence of allergens and may need to be confirmed using allergen-specific test methods. 2. High concentrations of alkaline sanitizers may cause false negative results, and peroxide-based disinfectants can cause false positive results. So before swabbing, make sure that the area is sanitizer and detergent free. So now let me show you how easy it is to use these tests. Allow the devices to reach room temperature before using them. Write the location of the swabbing site on the label of the tube for easy identification. Step 1. Sample collection. Remove the swab from the tube. When taking the sample, apply sufficient pressure to create flicks in the swab shaft. This will maximize sample collection and increase the accuracy of the result. Make sure that you do not touch the shaft when collecting the sample. Remember, we are protein. Touching the shaft can contaminate the test and cause a false positive result. Rotate the swab while collecting the sample to further maximize sample collection. When collecting samples from irregular surfaces, make sure to keep the sampling method consistent and swab a large enough area to obtain a representative sample. Now, replace the swab in the tube. Step 2. Test activation. The easiest way to activate the test is to hold the device in your fist and use the thumb and forefinger to break the snap valve, bending the bulb forwards and backwards. Next, squeeze the bulb to expel the liquid into the tube. Then shake for 5 seconds. Step 3. Incubation. Incubate the device for 15 minutes at 55 degrees Celsius or 30 minutes at 37 degrees Celsius using a dry incubation block. When the time is complete, compare the color of the liquid against the color chart on the AllerSnap label. Green means clean and purple means protein was detected. When collecting samples, do not focus on flat, easy to clean surfaces. Rather swab hard to clean areas and accumulation points. Swabbing here will give you a better idea of whether equipment was properly cleaned. In closing, Total protein swabs can be a valuable, low-cost tool to assess the efficacy of allergen cleaning, especially if you need to control multiple allergens.